Hi there. Most of this one you can do at home or on your own, and I'll explain to you what you need to do for the actual 3D modeling in class. So to start out with, for every element on the periodic table, it's going to have a unique atomic number. It's also going to have a unique atomic mass. These numbers are determined by the number of protons, neutrons, and electrons. The number of protons in an element is the same as the number for the atomic number. In fact, that's how it's determined. The number of electrons is generally the same as well. So you have 16 protons because the atomic number of sulfur is 16. And you'll have 16 electrons because the atomic number of sulfur is 16. To determine the number of neutrons, which changes from element to element, you're going to take the atomic mass, which is 32, subtract the atomic number, or the number of protons, which is 16, and that gives you the number left over as neutrons, which happens to be, in this case, 16. So to show all of that, all of those electrons, we have two different structures you can use. One is the Bohr diagram. To do this, all you need to do is fill in either a dot, or I like to fill in an E, an electron, because that reminds me what it is that we're talking about. So you can add an electron in wherever you want it to go. However, you always want to fill in the electrons from the inner orbit. Think about a vase. And if you have one of those vases that is narrower at the bottom, a flower vase, and wider at the top, and you want to fill it with beads, you have to fill it from the bottom. This is like the bottom of that vase. And each layer, each orbit, can hold a different number of electrons. So we start out with the inner orbit, and it holds 2 electrons. And then from there, you can add continuing in the next layers. So you want to add the total number of protons that you have here in the center, in the nucleus, and the total number of neutrons here in the center. And I would make those very small dots, and then fill in the total number of electrons, starting with 2 in the inner orbit and 8 in the next orbit, and however many you have left over in the outer orbit until you've got all 16 placed. Now, alternatively, we can use this Lewis structure over here, which is much simpler. You don't have to fill in protons or neutrons in the center. You write a big letter to represent the element's name, and then you add dots. But you only need to represent the electrons present in the outer orbit. So after you figure out with the Bohr diagram how many you have in this outer orbit, these are your valence electrons. And all you need to represent on the Lewis structure is the valence electrons. So you can put a dot to show how many valence electrons. Now let's do the math. If we have a total number of 16 electrons, 2 in the center, that makes 14. And then we have 8 in this next row, in this next orbit. So 14 minus 8 is going to lead us to 6. We only need to put 6 electrons in the outer orbit. And that's much simpler than having the full 16 plus what's going on in the nucleus. And we would organize them like this. And that will show us that we have 6 valence electrons. And then we already know that we have 2 in the inner orbit and 8 in the next orbit, because you can't have 6 valence electrons in the outer orbit unless those other orbits have been filled. So you're going to continue on and do the next elements. And please, above it, write down what the element name is. How would you find out the element name? Well, there's only one element that has an atomic number 3. But I also gave you a little hint over here by writing out the symbol for that particular element in the Lewis structure. So you'll do these next 2 examples here, and then pause it, and then come down here, and you're going to choose any element you want, and you are going to create a model for the electron cloud model. You'll look in your textbook to see how to do that, a Bohr model example, and a Lewis model. Now, the only 3 elements that you cannot choose are the 3 elements that you've already done up here, sulfur, and then these other 2 mystery elements, which you'll find out about in a minute. This one you wouldn't want to do anyway because it's beyond 10. Now, the reason you wouldn't want to pick an element that's beyond atomic number 10 is because it's just much more complicated to represent. So do an electron cloud model, a Bohr model, and a Lewis model. When you show me those in class, you will get the materials to be able to make a 3D model in class. All right, good luck.